So I'm going to be talking right now on software engineering in the foundational model era. Okay. So this is work jointly with many people. So as they usually say, if there's any mistakes, it's their fault. Otherwise, everything good is me, or is it the other way around? Okay. So, as I said, so we do use the word, foundational models just because it's not about the size, it's not actually about the language. There's many things, capabilities that are available today that are actually enabled by these foundational models. So if you see anywhere, okay, you would actually see in the news something like, the end of programming, okay? Programming occupation will become extinct. Okay, so I'm sure if you turn on CNBC or Euronews or whatever, you will see that news, okay? A quote like that. Now, this is a code that I got. The only problem or the only interesting thing about that code is actually from 1960, okay? Is actually when the punch cards were created. Okay, so good news is we're still around, and I believe computing and software engineering will still be around quite longer. And actually, today, the key point I want to say is this is not the end of software engineering. This is actually the beginning, because we're going to enable many more people to build software, and that's really one of the key things we want to emphasize. Okay, so what's really happening? So anybody, when you think of software engineering, you think of kind of that triangle, the usual triangle, which is the product, the process, the actors, or the people. Okay. When it comes to the product, we're now no longer talking about software codeware only. We're talking about this AI-aware, AI-native software. Okay. Now, when it comes to the process itself as well, we're talking about AI-native software engineering. Okay. So how do you actually build software using the capabilities and the productivity that's enabled with AI? And then, as of late, the recognition as well that we're no longer today working in teams, which is all humans. Instead, you're seeing more and more this, you have, humans, and you have AI agents. And even when you come to humans, you have people that don't have even a computer science degree are able to develop software. So it's a totally rechanging of all three tenets of kind of software engineering. And to give you a very concrete example about what I mean by codeware versus AIware, so any of this, if you have a car, a lot of the cars today have this rain sensing windshield wipers. So as you're driving, if there's rain, suddenly the windshield wiper starts operating, okay? Because it senses the rain. The traditional codeware way of building that software is you write a lot of code, okay? That code either has an optical sensor that interfacing on it, or an infrared sensor, or even an acoustic sensor. And based on that, it actually decides, there is rain, and then it will actually activate the windshield wipers, okay? And then when there's a bug, a lot of software developers sit together and actually fix that bug. Okay? Now, in an AI-aware world, what happens is you put a camera on that's exactly facing your windshield wiper, and it's taking pictures. You can take 1,000 pictures with rain on the windshield wiper, 1,000 pictures with no rain on the windshield wiper, and then you build a model. And then as the car is driving, every millisecond it's taking a picture. That picture goes through the AI for the model, and then the model says it's raining. This picture is a picture of rain. Then the windshield wiper will actually activate. Okay. So now when there's a bug, let's say you're driving and the sun is facing the windshield, and the model misclassified that as rain. The only way you fix the way you fix it is you just take a picture and you tell the model this is not rain. And then the model actually learns this, and next time it goes through, okay? Now, this is not science fiction. Today, Tesla, a lot of the cars actually have this technology. They have an AI-aware kind of sensor for AI-aware windshield wiper technology, okay? Now, why this is interesting? Because on the right side, okay, the left side. Okay, so on the left side here, okay, which is the codeware, okay, if you think of that's the big circle here is the complexity of code that you can write. So we are all the way at the perimeter there, okay. This is the most complex function you've ever seen in your life. So let's say it has 500 if statements nested in, okay. Okay, fortunately, humans are not that smart. As much as you might think you're smart, you're not that smart, okay. So you cannot handle 500 if statements, okay. So we have a capacity maybe under 5, maybe 8 nested if statements our brain just cannot handle, okay? Which means the complexity of the code that you can write as a codeware type of code, where you're writing the if statements yourself, you're limited by the complexity of that code, right? So that is kind of the dotted line, and so when you find the solution, you find that little blue X on there, okay? In the AI-aware world, instead, what we do is we give a lot of data, okay, which defines the boundary of a search space, and then the AI actually finds the solution, okay? That solution, if it's written as code, might be 500 level deep if statements, okay? But we don't have to worry about that because we're never gonna touch the code, we're never gonna maintain the code. Instead, what we're maintaining is the data that actually was used to build the model, okay? Which means today that the people that are actually developing that software don't even have to be, experts. Instead, we call them software makers. Every software maker, every person has their own interests. They define their own problem that they need to solve. They collect their own data. And then the models kind of enable all of that. So this enables to write much more complex software to enable much more sophisticated automation moving forward. Okay. Now, I think a lot of us at this stage, I hope agree that this AI-aware, this way of building this type of software, what this type of software enables is very interesting. But when you look around, what we're really doing for a lot of times is it's the same old kind of, a horse carriage, and people trying to fit on it an engine, okay? That is not gonna work, right? We need to really rethink the carriage itself, and this is what we would like to today discuss as a whole, as well as the different speakers we have today, okay? So to do that, we think of really, there's 4 big things, okay? So first is AI native software, so that's what I call like software where there's a lot of AI in it. The other thing is AI native processes themselves, so how do you automate, speed up a lot of the software engineering processes using AI? Then the AI native workforce. So you're seeing more and more in Silicon Valley this discussion about these tiny teams. So the team of 1 or 2 people, and they have $1 billion startup, okay? So we're seeing more and more of that. Small companies are able to create a lot of these big companies, and bring a lot of revenue. YC Combinator was saying almost all their companies in this in the YC 2025 class and 2024 class use AI to actually develop their software. Okay, and then me being as well an academic, recognizing that we need to change how we teach people software engineering, such that when they actually join the workforce, they don't just, get fired next day, okay? And that's what we're gonna talk. I'm gonna talk a little briefly today, and then throughout the day, different speakers are gonna talk, and then after that, we're gonna have a panel, and so on, okay? Now, there is no doubt that all this has to be done responsibly, okay? Trustworthiness is a very essential part. I'm not going to delve too much on trustworthiness. That needs itself another week of discussions, okay? But to give you an idea of where trustworthiness happens, when cars were created, the first way to make them safe was the idea there would be a person running in front of the car was a red flag, okay? That ensures that the car cannot run any faster than humans, so therefore it's safe, okay? Well, if you look around the streets, we don't have these people with red flags anymore, okay? On the other side, we have seat belts, but actually seat belts took 30 plus years to become a reality. Okay, so it needs to be installed safely, it needs to be done with trustworthiness, but that is a topic that I won't delve into too much today. Okay. So I already talked about this: codeware, neoware, promptware, agentware, and mindware. Okay, the different type of technologies, stages of software as it moves on. Okay. Now, one of the key things I want to emphasize, it's not like we're gonna remove all codeware or we're gonna drop all newerware. All of them will be combined. So the way we see it is, it's a combination of all these technologies. There will be software that is much better to be written with code, okay? There will be software that you can't even write it with code if you want, okay? And all of these are gonna be combined together, right? So, on the left side, you have all these foundation models on the bottom, and then, you have different programming languages as well, okay? And then you have machine learning, deep learning, and all these are kind of being combined together. And that's one of the things that, a software developer, software engineer needs to kind of figure out how to actually combine them together, getting the best of both worlds, of the multiple worlds they have to deal with. Okay. And the best way to think about it, this analogy we have here, so, on the left side, you have at the bottom, you have the CPU, so I'm going to use Java, okay? You have the CPU, on top of that, the JVM, okay? On top of that, there's the .class files, the JDK, so the programming, framework, and on top of that, Eclipse, VS Code, and so on. Okay. So when you look at that, you look on the other side now, what's happening, so in the middle here, if you can see it, okay? So in the middle here, you have people where instead of the CPU, we're no longer running them on a single machine, okay? We're running them on clusters. These clusters as well are heterogeneous, so they have GPUs, MPUs, DPUs, TPUs, and so on, okay? And then on top of that, there are, people have, for example, you run code on top, so like a Python code coming out of Python parsers and so on, okay, interpreters. Then you have things like LangChain, semantic kernel, and then on top they have things like LangSmith and prompt flow, okay? So from our side, what we've been working on is a rethinking of all of this, where we actually develop a new type of, IDE, okay, which is called the FMArts Hub. So it's a foundational model kind of IDE that's optimized where you're actually working with foundational models. So I think simplest example is how do you debug a prompt? Today, when you give a prompt to a large language model, it gives you a result, and it's not what you expect. There's very few technologies that actually help you to debug it, to say, this is the two words that really confuse the foundation model. Okay? Then below that, one of the key things is, whereas, the kind of the Python path, right, it does this kind of imperative abstraction. So when you look at the bottom of the cluster, what the cluster is running is actually running different calls, different inferences calls, okay? But this FMR's platform, what it does is actually it has a declarative abstraction. So what's happening here is you're running a graph, and because you're running a graph, you understand the impact of every node's execution, and you can reorder things around. So by doing that, you can actually do a lot more optimization because you're not running just different inferences, you're running combinations of inferences and actually real, regular source code like codeware, and you can optimize the execution. So then at the top, the user can actually see SLA kind of guarantees and so on. Okay. Now, there are many challenges involved in this, so I won't delve into much of them, but all of these challenges, so how to manage alignment of data, compliance, multi-generational software, how to control it, all of that actually addressed in that type of platform that has been developed, and Dai later today will talk a little bit probably on some of this. Okay. Now to give you an idea of why this is complex, okay, even changing the language that different agents are talking together with each other actually has a big impact on performance. Okay? So for example, so we had an application, and that application was written in Chinese. Then we had a team working on that application, but they don't know Chinese. So the different agents were talking in Chinese, so it was very hard to debug them. So they converted to English, and suddenly the application became faster. Okay? Okay, and why is that, right? So let me give you an idea here. So this is, the amount of tokens that actually, for the same, to express the same thing in different languages, okay? So you can see, so English is like the base, so it's one, okay? And then you can see things like, like Hindi is like 7 times, okay? So I speak Arabic, so Arabic is at 2.0, okay? Not so good, so we're twice as slow as English, okay? Now, this is not because Arabic is slower than English or that, Hindi is 7 times slower. It's because the foundation model, the tokenizer, is optimized for English, okay? So this is GPT-2 and 3. Then what happens is I felt even sadder because Arabic became even slower. It's 3 times slower, okay? So these are small things that you might not realize when you're working these foundation models, but a lot of these decisions at the bottom make a huge impact. And if agents are actually talking different languages, there's different impact, okay? And this is just talking English. So now instead people have structured, so you use XML, different structured, formats have different impacts, okay? So the whole performance engineering of application becomes very complex, Now, yeah, so go ahead.
Does it depend on what the model was trained on, or?
Yeah, so it's,
The language itself?
so the model themselves, the tokenizer for the model is optimized for the language, okay? So that's what's happening in there. There probably is as well something about the languages themselves, which is another area, yeah. Some languages are very, specific, some languages are a bit vague, okay? So yeah, so combination of both, but primarily what I'm showing here is the impact of the tokenizer, okay? Another thing as well to give you the how critical things are. So many of you, or at least a lot of people, have known about foundation models and got excited about them because you could do autocomplete inside the IDE, okay? Where people don't, so, what is Copilot, what is it called, Windsurf and so on, okay? The problem today is as the user cursor is moving, okay, the software needs to decide, A, whether they want to give a recommendation, okay? And second, they have to give the recommendation fast enough such that by the time the recommendation, like the request to create the recommendation and the LLM actually produces the recommendation comes back, the user's cursor is still there, right? Because if I'm giving you a recommendation and you're moving with your cursor fast enough, doesn't matter, right? So there's a lot of recommendations that kind of get dropped, okay? When you look at something like Copilot, for example, it will not give recommendations in the middle of a line, okay? So if it's a line, like you have an if statement and you change something in the if statement here, Copilot will not actually try to give you any recommendation in that space, okay? 30% of all keystrokes by software developers are in lines where there's actually other things already written in there, okay? So you see a lot of things are dropped in there. So now, if you really want a foundation model or software that gives you perfect recommendations, it's very simple. Every time you're in Java, every time you put a semi-comma, I will say you should do a new line. 100% correct, 100% useless, okay? So the size of the recommendation, the speed it comes at, where it comes at makes a big difference. So there's a lot of complexities in actually how to do that, and the performance of the whole pipeline is essential, because if I don't give it at the right time, it doesn't matter anymore, okay? So that is kind of more on the, some of the things that are happening in that space, which is this whole AI native software, okay? Now I want to talk about the AI native software engineering process, okay? And for that, I'll make it a bit more interactive, okay? So this graph here shows, the number of broken records in Olympic, swimming, and world championships since kind of the beginning of timekeeping. And you'll see there are two spikes. One is this spike here. Mm-hmm. Okay, yeah. One is this spike here. This is like in 1970 kind of thing. And there's one kind of in the middle of the 2000, okay? So the question now, this is the part where we're going to be interactive, okay? What is that was created in swimming that led to the spike? A lot of times when I do that, people tell me people created swimming suits, okay? No, people have been swimming with swimming suits for a long time. So it's not swimming suits, okay? What do you think happened that suddenly in around 1975 kind of thing, a lot of world records were broken in that year. So world and Olympic records. Yes, go ahead. Increase in public swimming pools, so more people, so a few years before, a lot of people were swimming, and then suddenly swimming became an active sport. No. Other things. So it's a technology, it's not like a social thing. Yeah, go ahead.
Maybe doping?
Doping. Maybe that's the spike before that. CPR. So it's very visible. Anybody can know what it is? Goggles, no glasses, okay? Maybe glasses for judges, okay? But yeah, goggles, okay? It's amazing how fast you can go when you know where you're going, okay? So now there's another one that was happening here in 2000. So can anybody guess what happened in Olympic swimming?
More measuring of what they were doing, how they were swimming.
No, it's not about the judging. It's basically, so what I'm trying to say is swimmers had a new technology that enabled them to become better. So one was the goggle. Swimming caps, not swimming caps. So, but very similar. So in 2000, okay, in the Olympics in Beijing, there was a new swimming suit that was created working with NASA, okay? And that swimming suit actually does a lot of compression on the swimmer's body, and it's kind of inspired by the skin of a shark. Okay? That swimming suit actually is illegal. You cannot actually swim with that swimming suit anymore. Okay? And the big controversy actually in the Paris Olympics was there were a lot of swimming records that were beaten that were actually kind of beaten with that swimming suit. Okay? So people were thinking that human can never get to that stage because that swimming suit gives you so much advantage. Okay? Yeah, so sorry, these are pictures of the LSR racer. Okay? Okay. So these are two new technologies. Okay? So the swimming process is the same, but we enable people to do it better, to do it faster. Okay? Now I'm going to show you another thing where we redefined how to do something. Okay? Okay. So this is Dick Fosbury, okay, and he's in high jump. So this is the Mexico Olympics in 1968. So what used to happen was high jumping is you actually run and you jump kind of like the straddle way. You jump facing, the straddle, okay? What Dick actually did is he actually decided, what happens if I actually jump backwards? Okay. Now, he actually won the Olympic gold. He never won another Olympic gold because he actually was not a top athlete. Because since then, everybody started doing this. Okay? So he changed the game itself. He changed the definition of how to do stuff. So why am I giving these two kind of examples? Let's look at now at software engineering, software development. Okay? So software engineering 1.0, okay, what happened here is kind of like the goggle days. Okay? So we had program analysis tools, have traditional process, so we have kind of requirement, design, and so on, okay? And we go down all of these, okay? So that's what we used to do in the old days, okay? Then software engineering 2.0, people, what happened is AI came, and then everybody looked at every single thing they had, so every process, whether it's coding, whether it's requirement, whether it's testing, how can I do that better with AI? Okay? So we still have, requirements, we still have design, we still have coding, the human is driving it, we're just making them drive it faster, okay? So this is similar to kind of where we created the suit, right? The LSR racer, okay? In software 3.0, which is the one we're promoting, his idea is that changing the game altogether, right? Rethinking what it really means to make software, okay? And actually figure out where AI can excel and where human can excel and where they can symbiotically work together. Okay, so how do you actually do that is kind of what we really want to discuss today. Okay, now, why we believe it's very important to do that rethinking is because while a lot of people think, well, with AI, we don't need software developers anymore and everything will be replaced by AI and computing, right? We believe that's not the case. And to give you a very concrete example, so anybody know what that picture is from? Yeah, so the thing on the right, which you don't see, is Deep Blue. It's the first computer ever to beat a human in chess, okay? And Garry Kasparov is basically a master, he is the best chess player in the world, okay? He was and still is, okay? He's one of the top players in the world, and it was the first time that actually a computer would beat, humans in chess. And now, realistically, no human can beat computers in chess, okay? So it's a done game. However, people still play chess, okay? And there are different ways that chess has evolved to still make it an interesting thing, okay? And to give you a very concrete example, so after he lost, he actually ran 2 tournaments. So in one tournament, he said, okay, I'm willing to play any other master chess player with their AI. So I'm gonna bring my AI, you bring your AI, and let's have a game and let's see who wins. So that was an okay tournament. The next tournament, which was really a big surprise, he said, anybody can come off the street, play me and my master chess players, and everybody brings their AI. And the surprise here was the winner of that tournament was not the master chess players, it was actually amateurs that really knew how to use AI well. Okay, and this is the kind of the quote he had, right? So he said, a weak human player plus a machine plus a better process, okay, is superior to a very powerful machine, which kind of makes sense, okay? The surprise here was that it is even superior to a master chess player, so a stronger player with a machine, but a master chess player that is not born and designed and breezes kind of the AI way, the AI native way of thinking, okay? And with that in mind, we do believe that this is the same moment for chess as as software development. How can we rethink what it means to build software? And if your organization does not do that type of rethinking, yes, you might have the best players in the world, have master players, master programmers, but you're not actually optimizing for this new world. Okay. And to make it more concrete, so this is the Go game, and this is so the graph here shows the sophistication of the gameplay. Okay. So the other concern that a lot of people have is saying, well, if we use AI so much, we're just going to become dumber and incapable, right? So this is a study. So the kind of the grayish, brownish kind of part of the graph here shows you the so that's the time where AI is being used. And the green bars here are showing the complexity of the gameplay of humans. And you can see that the gameplay by humans, this is assisted with AI, has become much more sophisticated. Okay? And we believe that will lead to the same. So developers that can build much more sophisticated systems can do much more sophisticated processes. Okay? So now we need to go back and ask ourselves, so how can we enable that as software engineering? So the core point we want to emphasize is, as much as everybody likes to have all these discussions about code and Java is better than Rust and C is the best of them all, code actually was never the end. It was just a mean, okay? Instead, the real complexity of software development and the core of it is actually the processes and the intent and the interaction, okay? That is actually much more important than the low-level code, okay? Therefore, today, if we can improve people's ability to express the intent, improve foundation models' ability to understand intent, that is a much more valuable contribution than actually helping produce code more, okay? So what we've been doing is, for the past 2 years, we've been kind of rethinking the whole software engineering and software stacks, figure, okay, how we can have teammates at the top that are helping you to develop better. What is the definition of a new IDE? What is the definition of a new compiler? What is the definition of actually the runtimes that you're running on? And at the bottom, what kind of foundational models we need beyond the current ones today that are available. I'm going to run very quickly through a lot of these, okay, to give you a flavor of this. You're going to see a lot of QR codes, so you can scan them as we go through. So as I said, unfortunately, as much as everybody wants to get rid of humans, you need humans because at the end of the day, you're building software for humans, okay? And unfortunately, humans are not so smart as much as they are, okay? So we need to figure out what's the part where a human will do good and what's the part where AI can be doing good. So we believe the requirement process, that is so essential, having the human in the loop, right? The realization process, implementing something is where the AI can do very good. Because the AI, we can give the AI one requirements, they can produce 20 different versions, implementations. It can even judge them and then come to the human and say, here, I have 2 examples for you. This and this, these are pros and cons. Which one do you like? And then the human can say, I don't like this, give me this other one, okay? So this loop of actually realization could now go from months, to hours or minutes, okay? So really this idea of conversation-oriented programming where code is a new binary, okay? And if you actually track the conversation, you archive the conversations, you actually can reproduce the whole code base as the large language models evolve, right? Okay? So it's very important to start tracking that discussions that the humans are having with AI. Today, very, very few of these agents today actually track that discussions. And still, unfortunately, we're only tracking the source code. Okay? So really, when you can think about it, we kind of evolved from this classical environment, VS Code, okay, which was code first, to Jupyter, which is computational AI programming, and then this AI plus human, co-programming editor, okay? And what exactly does that mean, right? So this one is more chat first, it's agents involved in it, and how do you do that? So briefly here, so there's something called theory of mind. So the idea here is, today, when you ask a foundational model to do something, okay, we ask an agent to do something, okay, and they don't do it for you as you want it, a lot of the time assumption is always because the foundational model is incapable, okay? But the reality is there's a lot of assumptions that we have about day-to-day life, okay, that these foundational models don't know. So the best way I tell people, think of them as an alien that came from space, okay? And the very concrete example I say, so I can see everybody came to today fully dressed. Nobody came naked, okay? However, there was no requirements that said, please, you need to come dressed, okay? But somehow we as humanity kind of agreed on that, okay? We're gonna come, fully dressed. Now, if ChatGPT came naked, who's at fault? I'm the one at fault. I never said that, okay? Okay, so it's important. Now, the key thing is, so I need to tell that to ChatGPT or the foundation model, my coding agent, okay? That's one. So I need to tell it kind of what's in my mind. And second, and more importantly, is if I tell it to it once, it should remember it, okay? So if you have example, an assistant, and the assistant, you tell them, go get me a coffee. But you didn't describe whether you want a decaf or whether you want it from Starbucks, and they just got you a regular coffee, okay? First, you're at fault, at that stage, right? Second is you explain to them and you correct them. The next time, you shouldn't repeat that again, okay? So that's the stickiness aspect that's essential, okay? So I want to show you a kind of demo of a type of this IDE that has been developed. Actually, Kahilia, which is right there sitting here, he's one of actually the developers of this IDE, okay? That IDE is very conversational. So on the right pan, you'll see there's a discussion going back and forth between the AI and the human, okay, to create you want a newsletter that's sent to you on a daily basis with things about sports, and it asks you back and forth. Once it has enough good understanding, then on the upper left corner, it will actually write down the requirement in very detail, and on the lower left corner, it will actually tell you how it plans to implement it. Okay, so basically he's asking, I want to get a kind of newsletter. I want to get it weekly. Now the AI is asking, okay, why do you need that? Okay. And then kind of what kind of topics you care about, what kind of websites you want to be able to, what kind of the sources. Is it for yourself or for many people? Okay. So it's going back and forth and having that discussion. And the idea here is the AI is really working with you to define the requirements well. Because we think today it's more important to understand the requirements, understand the needs of the user, than to help them generate code. Once we know what you want, we can generate it very fast, okay? And the nice thing, which as many of you have worked on big projects, is you might think you want X, but then now after you finally get X, you say, that's not what I want, but now you're too ashamed to tell people, can we change things, right? But now if we can make the realization process so fast, then people can innovate and really understand really what they truly want, okay? So now it did all of that, then actually now it can actually figure out the requirements, very detailed requirements, okay? And then on the left side, it actually writes down how it actually will go doing that, okay? Now, one of the things we did is actually now we added support for actually debugging in there, okay? Why debugging is challenging, okay? So the biggest problem today was a large language model. If you tell it to do something and you tell it, explain to me why you're doing it, or tell an agent to do that, there's actually a good chance that the agent will change its mind and act differently, okay? So imagine turning on debugging in your application. As soon as you turn on debugging, now the application works. You turn off debugging, it doesn't work, okay? So this idea of having the kind of like a surrogate agent that's looking at the real agent and trying to kind of decipher why they're doing stuff is one of the techniques we use to actually do debugging for these, okay? Now, so what we really have done here is, so you can see the human here, and there's a little snail because the human process of thinking is much slower than the AI, okay? And the human has to use a lot of their brain to figure out how to write code, okay? And then Copilot kind of generating the code goes through the compiler, you get the binary, and we're having that loop, okay? So this is the kind of the old way of thinking. The new way is the human and the AI having these conversations. These conversations are tracked, they're version controlled, okay? And the idea here is the human is trying to, provide intent, provide clarification, okay, reflecting on things. Then once the agent has all that, the agent goes ahead, searches for the big space, tries different implementations, pros and cons of different implementations, and comes back and reacts to the output, okay? So this is what we call programming 3.0, and this is where we think more and more value will be coming from using AI. So, this is where you will get that 100x developer or 1000x developer productivity. Okay. So I want to show here, this is a demo of developing kind of an application, a mobile application, by just discussion, okay? So you are not touching any code, okay? So here he's going to develop a to-do list app, okay? Okay, so then now the agent will give it, okay, these are a couple of recommendations for the to-do list app, and then immediately pick one of them, okay, and you can actually interact with it. So throughout this whole process, the developer, the user is not seeing any code, okay, and then they're trying to say, okay, well, how can I enhance my app? Then it actually gives them a lot of recommendations of how to enhance the app, okay, and then you say, I like this one idea in there. So for example, I want a customizable theme, okay. So you say, okay, I want to toggle, this dark mode. So I want to be able to have a dark mode switch. You say, make it happen, and boom, it immediately happens, and you can see the dark mode switch on and off. And now, because we treat this conversational as actually like history, and it's archived, we can actually roll back in time and say, I don't want this feature, I want to go back and forth, right? So in the back end, yes, there's still source code, there's still a lot of documentation, everything there, okay? But at this moment, we're not doing that. We're just discussing at a high level, okay? Now, as we started working on this, we did reach the conclusion there are some times, where they say a picture is worth 1,000 words, and as well an equation is worth 1,000 words too, okay? It's much harder to tell people an equation than just to type it in, okay? So it has the ability of what to say, now get out of my way, I want to do a surgical thing, I want to actually add an equation example, so you can get in and add that as well, okay? So easier to code than chat, just go ahead, you can actually do that. Okay. So we're seeing more and more of these happening today, okay? I think Anthropic had something a month ago along these lines, okay? At this stage is to build what we call the micro apps, small enough apps, right? But we can see more and more of that evolving as we go, okay? So with that in mind, what we're really reaching, our opinion here, is this idea of duality of software engineering, okay? There's really software engineering for humans, okay? And there's software engineering for agents. And the software engineering for humans, which we already had before, instead, the human has actually been lifted off a bit from the code, and instead now, instead of having an IDE, we have an agent control center, like an ACE, okay? And then the human might want to jump into the IDE to do changes, but most of the time, the human is running at the top, okay? And the software engineering for agents, now, it has its own agent execution environment. And the reason is because agents' capabilities and what they're comfortable for are very different than the human capabilities, right? Agents could run for hours, okay? Agents could sift through so much code, okay? Whereas when you look at what we have done in IDEs is we have tried to simplify the IDEs to the limitation of the cognition of humans, okay? And if you look today, a lot of the coding agents that are available, so either from Anthropic or Google or OpenAI, all they use is grep and just code reading, right? They don't use all the sophisticated techniques that have been developed to remove, the cognition, to simplify the cognition. Okay. So now I want to briefly talk and give you an idea of some of the studies we have just been doing recently in the last couple of months. So this is a data set called AI Dev, okay? So this is actually looking at coding agents in the wild, so Codex, Devin, Copilot, Cursor, Cloud Code, and you can see here that, over 1 million changes in open source today are done by these autonomous agents. So this is fully, independent. You just give it what you want, and it will just get it done. Okay. This picture here shows you So the dot, so you can, so for example, let's look at the orange one, right? So every one of the kind of the axes is a different type of of a change request. So a fix, a performance optimization, a refactoring, documentation. Okay. The dotted line inside tells you the success of a human created PR. So humans submitted, say, 100 PRs. 80% of them actually, were successful. So it's 0.8. Okay. And then the colored one shows you the success of an agent. Okay, and you can see, for example, when OpenAI Codex is actually as good as human, if not in some cases even better than human. Okay, you look at Claude Code, so the red one in the lower right corner. Okay, for some things like refactoring performance and style, it's not used at all, or the success rate is very low. But in other cases, when it comes, for example, build fixes, it is actually exceeds the human capabilities. Okay? And this is just the beginning. Okay? Now, the new bottleneck actually is silence. So today, a lot of these agents are able to do work so fast that a lot of times what ends up happening is the human did not actually respond because they're just overwhelmed by so many of these change requests happening. Okay? So so now we've totally changed it. It's no longer about how hard it is or how much time it takes us to write the code, how much time it takes us and effort to review the code. Okay? So you can see here around, as much as 50% of the changes, just nobody has acted on them at this stage. Okay? Now, why things fail. So this graph here shows you why things fail. So for example, let's look at our obsolete. So that means the human did a PR, and then by the time the PR was submitted, the project says, this PR no longer makes sense anymore, okay? Around 26% of PRs done by human actually have that. So even after everything is done, the project says, yeah, it's good, but this is no longer a problem. The rest of the table where it has it like with X means, codex versus human. So if human is at 26%, okay, codex is 0.4, which means that because the codexes and all these agents can do things much faster, so the chances of them doing something and by the time it's done, it's not relevant, it's extremely low because they're much faster, okay? Now, in some cases, they're not great. For example, you could look at the 5-point, so in the lower right corner, you have a 5.6, so that means like almost 6 times worse, okay? So this is where an agent would do a PR, but then the reviewer, the human would say, this PR is way too big, okay? So I'm not gonna accept it because it's way too big, right? In the human, it's 1%. So this means, for Claude, around 6% of the times a PR is rejected is because it's too large, for example. Okay? Good. So this data is available, for other people to actually use. So we have actually provided the data for anybody who wants to investigate because, a lot of people are actually very interested in, how you can do that and what are the pros and cons of these agentic PRs that are done by agents. Okay, now I'm going to run very quickly for the rest stuff. Okay, so runtime. So we've been actually, as I said, remember I said, in the past, everything ran on the CPU. Now it runs on these heterogeneous clusters, okay? A lot of these clusters are many types of compute, so CPU, GPU, every time with these computes, some of them are very costly, so using a GPU and not, locking it and not using it has a lot of cost overhead, okay? So we've actually been working on redeveloping the infrastructure at the bottom. So GPU is an expensive compute, is not locked. It actually can be reused across different executions at the top. Okay, and we've actually been integrating some of this work in the Ray project. So Ray is almost, you can think of Ray as, in my opinion, as the Linux of the cluster. Okay, so it's a new type of platform that you can run many things on top of it. And today the main routing algorithm, the scheduling algorithm of Ray, it comes out from actually our team in optimization of this multi GPU, NPU, and CPU execution, which is the case for all of these agentic workloads. Okay, We've actually as well kind of developed enhancements for people that want to develop IDEs on top. Okay, again, when you're working on IDE, sometimes the user wants to give a request and the agent works for 5 minutes. Another time, the user just wants the return to come very fast. I'm doing code completion. So all of that, we need kind of like this platform today that can guarantee service level agreements. Okay, we've well actually implemented another thing on top, realizing that one of the beauty of software development is you can actually code anywhere, on a plane, on the beach. But if you actually have to do that connected to a cluster, that's gonna kind of defeat the purpose of the fun of programming, right? Okay, so we've developed this technique that actually has this layered foundation model inference. So it's kind of a little bit like Apple AI. So what it does is there's a local foundation model, okay, and a very small one, and there's a big one in the back, okay, and then the local one tries to solve the problem. If it cannot, it will actually go back to ask the big one, okay? The big difference between this one and Apple Intelligence is, for our case, if the small model does know how to use it, it will actually go to the big model, ask it to do it, and ask it as well to teach it how to do it, so next time I don't come back to you. And what we found is after a couple of days or a couple of weeks of using this, the chance of you going back to the large model on the cluster becomes lower and lower. Okay. Finally, this idea of the foundation model themselves. Today, a lot of foundation models are built by just putting as much data as you can. And today, one of the biggest problems is we are running out of data, okay? And second is it's becoming very costly to build these foundation models. So what we've been working on is this idea of actually structuring, saying, to build this foundation model, this is the type of data I want. And either you curate the data or you synthetically create the data. So it becomes much more of an engineering process instead of actually what data is available. And if that's the only data available, I'm just stuck using it. Okay. So this is kind of giving you the two differences between, I'd say, SE 2.0 and SE 3.0. Okay. So, the idea is the teammates here, they're self-evolving, they're personalized mentors. The idea is more on conversation, more on intent, not really on the code. Okay, I didn't talk about the compiler, but the idea here is we moved away from writing if statements instead to make a search space exploration. Okay, and then the runtime, we're moving away from serving models to serving, what we call them AI-aware compound apps. And then finally, the foundation model, instead of data-driven, kind of opportunistic, instead actually how you create the data that you need. Okay. So this is kind of what I talked about, the AI-aware native software, the AI native software engineering process, the AI native workforce. Now I want to just one more minute to talk about pedagogy. The biggest problem today is, so this is how the world looks like today. You have these software makers, people that like to write a lot of macros, Excel, some, long Excel scripts and stuff. Then we have a lot of junior developers. Then we have a few senior developers. The problem today is the future is there's going to be a lot of people that can dabble and can do stuff themselves, build their small micro apps, okay? And this middle ground, the junior developers, we won't have that much of them, okay? And that's a big problem because the problem is you need to be a junior developer to be a senior developer, okay? So that's one of the biggest challenges today in education is how do you actually make sure that people that are graduating today can immediately be these senior developers. So that's one of the challenges we're working on. And happy to get feedback from people. This is one of the problems my department shares on my case, okay? So please help. Okay, good. So in the last, 45 minutes, you're becoming Superman, Batman, okay? So I talked about this whole AI native software, okay? Software where actually there's a lot of AI in it. There's very little code in it, okay? I talked about this FMR, which is kind of like the next generation IDE, where you're building software that has agents, has foundation models, very little code. How do you debug that type of software, right? Okay. Then we talked about AI native software engineering process, the whole workforce itself, the pedagogy. Briefly, we talked about, we need to go away from thinking that code is the center of the universe in software development. That was just a mean to an end. And then finally, I talked about, this AI dev data. So if anybody would like to see how today these, autonomous agents are being used in the wild, we have a data available that people can kind of play with. Okay, so that's everything. So happy to take any questions. Thank you. Okay, yeah, well, you go ahead.
Thank you for the talk. Very interesting. So, what is your opinion about the
Maybe.
maintenance and the?
Oh, sorry.
Okay, yeah. So, thanks for the talk. So you talked a lot about how AI and agents are going to change how we write software, but like, what is your opinion on how the maintenance and the evolution of the software is going to change, or like how is it changing now?
Yeah, so that's the key point today is a lot of people use AI to develop software, okay? But today the only thing we archive is actually the output, which is the code, right? But the reality, we believe what's even more important is that discussion, the high level descriptions, all that, which is the things that we've always wished developers would write down. It always stayed in their head. But now for the first time, because they see value to talk to an agent, they're willing to write it down, but then we don't archive it. So we think that type of information needs to be archived to speed up the evolution and the maintenance and all that. Yeah, I agree with you.
Yes. Thank you for the talk. So my question would be regarding a couple of statements that you made. So you have made this example, gave this example of these Y Combinator startups being like one-man parties. And then you also mentioned this fact about the amount of code that is being actually pushed by these agents is exceeding the amount that these developers can actually handle. And there's also been this talk about how we as humans have gone from the developer role, or are going from the developer role to the reviewer role. But it seems that we're also becoming unable to actually do that reviewer role due to the surges of like reviews coming in for us as developers. Do you see a shift happening, even from us being the reviewers, to something more meta? So like rather conformance checkers, rather than actually reviewers of practical code?
Yeah, so there's two things. So today we use the AI to help us write code, okay? You can imagine using AI to help us write what we want the agent to do, so the requirements, okay? Same thing, today we are manually reviewing the code. Then there is automation for reviewing the code. But actually what we really want to be reviewing is we want to review as well the thinking of the agent that went to that, right? So the whole field needs to go one level higher, okay? Then we're going to optimize that. Then we're going to, yeah, so the idea is we keep on going higher and higher. But right now we're still, as long as we're stuck in code being king and code is everything, we're not able to jump to the next levels. And I agree with you, yeah.
All right, do we have more questions? I'm gonna go over there, come back.
Hello, Professor. Thank you for your presentation. One of your sentence was that currently the thing that is matter is not about the complexity of the code, but the complexity of the process for the AI applications. Where my question is that if we think about the complexity of the process, the way that we give the prompts to the agents, or the way they handle things, they give us the code, do you think that still the issues or the challenges arise when the complexity is high? For example, the complexity is correlated, why the lower maintainability, lower reliability of the softwares. Do you think that still the complexity in that sense also is going to have the same challenges, or maybe introduce new challenges?
So I'm not sure I get, but so you're saying as we go higher in the abstraction, there's going to be complexities in there as well. So so complexity exists no matter what, right? Anything outside the world has complexity. The biggest problem today was there was that complexity, and there was the code complexity. And developers' time was spent, here and here. And if we can outsource that implementation complexity to somebody else, okay, then we can actually focus on the kind of the inherent complexity. That's one. Second is a lot of times the complexity in software development comes to getting to know what the customer wants, and the customer themselves don't know what they want, okay? So they say they want ABC, you spend 3 months giving them ABC, and then they say, oh crap, that's not what I want, okay? But now if that loop becomes so fast that next day in the morning you show them, is this what you want? It might not be 100% working correct, but they see it very quickly and say, oh, no, I was so wrong. Let's go here, let's go there, right? So actually, I think it will help even control that complexity. But there is no doubt there is a need for automation and management of complexity in the domain level, same as we had complexity at the code level.
Yep, thank you. Just
Okay.
for adding that. The complexity for the general programming languages, such as, for example, Halsjet complexity, cognitive complexity, rise from the structural complexity of the code. Nowadays, because those introduce challenges for maintainability. If the code is complete, it's possible to needs more efforts of maintainers to maintain the code. Also, it can cause errors, so the reliability also decrease. Here, we are talking that if the complexity of the process is challenging. For example, you give a prompt and you receive an application which doesn't work, means it's not reliable, or if it's work and then it's based on some errors, it needs maintaining. So I think still the challenges remain. So I want to know that to what extent do you agree with this, or do you think that also there are some new challenges, or it's just going to help the previous challenges solve?
Okay, so I'm gonna, you're next, right? Okay, maybe come up and set up, and I'm gonna answer your question, and I'm gonna take the question in the front and then, okay? So the biggest problem today is we're developing this type of software using almost like only text editors, copying and pasting, okay? So the world needs to evolve where we actually need to have an kind of like an IDE for that type of software, okay? That will help with the complexity of the process, in my opinion, okay? So we're working on that, and I encourage other people to do that as well. You know, it's almost like we're developing this very complex software, but at the same time, we're using like punch cards, okay? So that needs to be changed. Oh, you need a.
Yes.
Okay, we need a finger. Okay, we have more time. Okay, we'll take that question here, and then we'll get you a connector.
Hi, thank you for the presentation. My question is related to the software engineering 3.0 because it's about the agents with reasonable capabilities. But probably you saw that recently a paper was published about that the models actually can't reason. So what is the impact of this published paper, and what do you think will happen next if the models really can reason? What will be the impact?
Is this is the Apple? Is this the Apple paper? The reasoning paper? Yeah. Okay. So the Apple paper has a lot of mistakes in it. Okay. So that's one. But let's go with it's okay. It's okay that it has. Let's go beyond it. Doesn't have mistakes. I think first you have to realize that actually. I would say for most software developers, 60% of their work is actually monkey stuff, very dumb, very simple stuff, okay? If we can actually automate that 60%, okay, which I think models today are able to do very well, you can do very fast, you know, iteration. So for example, I need to compile it, I need to copy the file, I need to reconfigure this, blah, blah, blah. If all of that is happens very fast, it's amazing what you can do, okay? So that's, you know, at least the one thing I in my mind. And then the second is you have to, we've always thought of software as it's either right or wrong. We've never thought of software that grows with us, okay? So, you know, when you join a company as an intern, the first month you're not the best, okay? The second month you're better, the third month, the fourth month, and so on, right? So we need to think of how we can develop software that grows with you, because in my opinion, you can hire, so you can have two cases, right? You can have a person that, you know, went to MIT, amazing, you know, PhD from there, and you have a person just dropped out of high school and have been working in your specific area forever, okay? That person, their experiences, that kind of the learning they have done is gonna be much more valuable to you in an industrial setting. And today, when you look at a lot of these autonomous coding agents, a lot of them enable the user to actually customize give basically, you're almost teaching you, you're becoming a mentor. So the human now, which is another skill that we need to teach, young people, right, is how do you mentor an AI such that, yes, it's not good today, but in 2 months, it's so much better.